Welcome back to the CNC plasma build, and this episode we'll finish off building all the electronics and then we'll 3D print a custom control panel in 2 colours and get that installed onto the machine. We'll then wire up the connectors, the 2 GX16 control units, one for the torch height controller and the other one to control all the logic, and then we'll have a look at the wiring diagram to make sure we're going to wire that up correctly, and then we'll move on to the torch height control unit and get the demo working to make sure it moves the head up and down correctly in test mode. And then finally we'll write some custom macros to do the touch off and find the top of the workpiece. Let's get into the video. Welcome back to the workshop and welcome to this ongoing CNC plasma build series. So in the last video we got the gantry moving, we got the software hooked up and some basic configuration done. But I wasn't super happy about some other things. Obviously I've got a keyboard and mouse temporarily set up here. So I was going to put a little plate there with a keyboard and mouse on it, but it's all getting a little bit bulky. So have another think about maybe getting a touchscreen there. While we're in that area, I wasn't too keen on the little mini PC back there. I was going to get some sparks on it, need some protection. So I've got some thoughts on that. And the other job in this video is we need to get all the plates finished. Or finish off the cover that goes on the side there, get everything painted, and get the little labels put onto the controls there so you can see what they are. So for the label, well, I've got a 3D printer, so I thought I'd give it a go. And this is because it's a Bamboo Labs P1S and it's got the AMS system on it. I'm able to print in multiple colours, up to 4 in fact. And this is obviously a 2-colour print. And you can see I've just kind of painted on the last few layers in white. That looks really quite nice. So let's disassemble the front panel. I need to remove some of the controls. We'll get this on and then put the controls back on and see what it looks like. E-stop. That's just 2 wires. Okay, before we take this off and paint it, let's just make sure it's actually going to fit. Looks pretty good. I won't take it apart, but that looks like that will fit in there okay. Okay. Right, I think we'll take this off, take the fan off, clean it up and spray it, and this can be our first complete panel. I'm using this Rust-Oleum gunmetal metallic. I've had good success with it on my CNC machine, so I thought we'd use it here. Okay, so I've just finished putting all the buttons on. All still move okay. I think I've wired it up correctly. I had to refer to my wiring diagram there, but hopefully that's okay. And I think this looks rather neat. It's amazing what you can do with a 3D printer these days. Yeah, so it looks great. And the rest of the panels are off because those are painting over there. Well, they've been painted and they're drying. And we'll put those back on. And then we can assemble it back onto the machine. Right, quick update then. So all the panels are now painted and they're back on the machine. And I've made quite a few other little changes as well. Okay, so I went online and bought myself this little 17-inch touchscreen. So hopefully that'll do the job. And then you'll also see there's no PC at the back there. Okay, so as you can see, I've just got the monitor mounted on there now. The computer's moved. I've got that mounted direct. That's a little less bulky. And we've got our 3 cables. So we've got our mains IUC cable, the VGA. And then for the touchscreen, it needs a USB supply, which is what this little one is here. Okay, so the mini PC's here. This is the model. It's the Optiplex 3050. Got headphones, jack socket there. We've got a couple of USB sockets there. Got 4 more on the back. Got HDMI, although that monitor doesn't support that. That's interesting to have. A display port there, and then the one we'll be using, which is the VGA, and then we've also got our network port there. It's got a little lock thing, so you can lock it to a desk, I guess, for office use, but we won't be using that. And then power goes in the bottom, and then that is going to go down here. And then we've got our power still, and we've got a USB connection. That's to run the touchscreen. Now I have just ordered another USB extension which will go from here, come out the unit and go up to near the monitor, and I'll probably build a little kind of box at the side. I may have an e-stop in there as well, so we've got 2 e-stops rather than trying to have to bend down on the machine at the front panel and push that one. Then that'll allow me to put my little USB thumb drive in there, and so when we're loading G-code in, I can just push it in near the monitor rather than to have some kind of access in the panel or something back here. So we'll have that remotely supplied. Yeah, I think that's about it. So just 3D printed these little brackets that hold it quite securely in there, and then I've got some ventilation holes that I put in the front round here because it's got to allow the air to go through. Right, so the next step is we need to start wiring up the plasma machine. Okay, so here's my plasma machine. So we've got our 2 outputs there, GX16. So this is a 2-pin for the torch height controller, so that monitors the voltage. We've already made up that cable and got that wired into the sensor over there, or the torch height controller over there. And then we've got our logic controls here for firing the torch and monitoring the arc. And that's a 5-pin GX16. Now they do give you a little pigtail that comes with the machine, but I made up my own, so I've got my own connector there. Because otherwise you end up with like joins back here and heat shrink and multiple heat shrinks over the top of each other. It doesn't look very neat, and I think that looks a bit nicer. And that then goes to this inside the machine. I've just got to route this to the different areas. So in terms of how I'm going to wire that, that's my 5-pin down there. 1 and 2 are joined internally. 2 and 3 get joined on the relay. So they come across here. So when the signal is sent from here to fire the torch, closes the fire torch relay, joins those 2 together, and that will join those 2 together, and the torch will come on. Once it's established the arc, there'll be a signal where it joins 4 and 5 together inside the plasma unit. That essentially then put that 24-volt signal to the arc OK, which again goes into the control unit, and then it knows the arc's ready and you can start cutting. So when you power up the relays, they energize the coil, and then when you switch them off, that energy goes back the other way and it can go back into the power supply. And if you've got sensitive electronics like MOSFETs or transistors controlling that, then it can damage them. So to be on the safe side, I've just put these flyback diodes across the positive and negative parts of the coil. Okay, so just temporarily put it back together with some Velcro straps on here in case I need to take it off again. So I've just put the 5-pin plasma control system in, and I wired it all up to the relay and to the AXBBE unit. So hopefully that's all going to be okay. And just put all the trunking lids back on again. So I think the next thing to do, we'll put the PC in there and hook that up, and then we'll switch it on and see if it works. And before we do that, I've got one of these labels down there, but it's a little bit hidden, so I'll make it a bit more obvious. Just make sure everything's out of the way. That way, yeah. monitor cable. We've got the power, and it's the USB that runs the touchscreen. So in the last video I had some comments about screening. Obviously it's a plasma cutter and they can put out a lot of interference. Now I've hopefully played it safe and gone for a CNC compatible model. So this one's the blowback style, so it's not the high frequency start, which would be a lot more challenging. So with the blowback style, as I understand it, should be a lot less interference when the thing initiates. But to be on the safe side, my motor cables here, the stepper cables, have got screening around the outside, and that's what this little earth cable is here. That goes from the screen and runs down to the main earth terminal blocks under there. Decided to connect that in the end just to play it safe. And then step and direction, including the ones that go down to the torch height controller, which is inside there, twisted pair, try and minimise the signal interference that way as well. We've got Ethernet as well, which is supposed to be a bit more noise immune, and I've just tried to keep the main 240 volts down here out the way, away from the more sensitive electronics as best I can anyway. It's a bit crowded in there. And then the voltage pickup off the which comes out the back of the plasma, which is sensing the voltage. That cable immediately goes out the box and runs around the back to the back of the plasma unit. Again, trying to keep that cable really short. Also give access to the torch height control at the front, so you can actually use it, but get that wire out of the way. So hopefully I've done enough. Alright, well here goes. We'll turn it on and see if it still works. Okay, we've got power on, so that's okay. Oh, does that say keyboard not found? Yep, okay. That should be okay because we've got the touch screen. I think I mentioned it earlier in the video, but I went into the BIOS of that and set the power saver configuration. So when you provide power, it turns on straight away, otherwise you'd have to reach in and press the button. Now I did cut some of the holes out there to make sure you could get your finger in if you needed to in emergency start the PC, but it seems to be working okay. Alright, so far so good. Let's switch on the unit down there and make sure everything's okay, and then we'll go into the software. Okay, and we'll reset. Okay, that's good. The relay just triggered. Let's just check that. Yeah, okay. Everything's e-stopped. Let's go again. Okay. Alright, looking good. Okay, so here's our touch screen, and we've got our plasma software there. Yeah, I noticed this one did a test run earlier just to make sure it was working. That double touch doesn't seem to work. I wonder if there's something in the configuration. So what I managed to do, yeah, I've got an on-screen keyboard down there. So if I single touch on there and then press enter, then you get the double. Okay, that's looking good. And so in theory, let's just check on our diagnostics page. Here we've got the e-stop is, so it provides 24 volts all the time. And then if you break that circuit, that's when it trips. So it's telling you got 24 volts in, but we haven't got an e-stop triggered. Let's just give that a go if I press the e-stop button. Okay, great. Reset that. So in theory, we should be able to reset there, which we can. And we should be able to move the machine, which we can. And it's reasonably rigid, so I can actually Alright, so it's all working as before. So the new bit I want to configure is to control the torch. Now, I don't really know how we do this, but let's have a look. So we've got the e-stop. Oh, probe, yeah, I've got that set up as well. So when it touches the material, it'll go in through pin 4. But I haven't done anything else about that. And got torch height control. Possibly we do it there. What else have we got? input output trigger. Okay, so it won't be any of these. Okay, so to control the torch, I've got 24 volts coming through this relay here, and if it's active and live and not in e-stop mode, then the contact will be across there. So it will put 24 volts down to pin 7, which will go to this side of the relay, and that will go to the fire torch, which will come in at O2. And then when I want to fire the torch, I guess inside here that will ground that, but it'll switch that anyway, and that will allow the relay to activate, and that will bring terminals 9 and 5 together, which are torch on and common, which go to that 5-pin GX16 connector. So let's see, yeah, so that should be on to common. Yeah, so it'll join 2 to 3, and that should fire up the torch in theory. And then when it does fire up and it's okay, we will get a 24 volt signal from pin 4. Will go through the plasma system, the contacts will be made inside the plasma, and it will send an arc OK, which will be 24 volts down here, which will come in I5, and then the system will know the torch has established the arc and it can start cutting. That's the theory anyway. As I mentioned before, we got a diode across this coil and a diode across that one for flyback, sort of back EMF damaging, especially inside here. So now we've just got to figure out what we need to do on here. Right, so I guess we enable that. Come on, there we go. And the arc is on pin 2. Oh, this is fun. Alright, on port 1. And active... I don't know which way. Oh, let's just try it. I can't think which way around it would be. Okay, let's see if it will save those. Oh, it's cleared them. Okay, because we've got torch height control actually built into the main the Proma unit, so maybe we don't need to do that in here. How do I then? I need to go and have a look. Okay, I've done a little bit of research on the internet, and it looks like I needed to set it up in the spindle axis page, so we'll do that. Also, I gave up using the touchscreen for all that messing about, so I've got my keyboard and mouse plugged in. Once we've got it configured, we can take those away, or maybe I'll have like a wireless keyboard as a kind of a backup that I'll keep in a drawer if I ever need to make any changes. Right, so this is the screen. So on the axis setup X, Y, Z, I'd already done all those. I hadn't noticed there's another one over here called spindle. Now we're not using PWM or step and direction for it, because it's not a spindle, it's actually a plasma, but I can't switch those off, so hopefully it'll ignore those. And then I've got spindle relay output enabled, and I've just put that on pin 2 of port 1, because that's where I've got it connected, on pin 2 of this port, and hopefully that should drive the relay. Now down here there's a 1 second delay, so we can mess about with that, I'm sure. Let's save that and go into here. I don't know if one of these buttons actually switches plasma on off, but we'll do it manually. So we'll do M3, and it should trigger the relay. Did you hear that click? So that one's come on. It's actually worked. Right, so if we type M5 in the MDI, we should switch it off, which it does. Oh, well, that was easy. So we've just got the relay in shot. I don't know if you'll be able to see the LED come on there. So it's that lower one just there. And that looks like a plasma to me. So if I push that, yeah, it's come on. Wow, okay, so far so good. Right, before we hook this up to the plasma machine and risk any damage, I'm just going to see, being careful because we've got live voltage down there now. So between 1 and 2, they should be permanently connected, which they are. Yeah, so between 2 and 3, 3 pairs of hands. Tell you what, right, between 2 and 3, that is open circuit. Switch it on. And that's joined it together. Okay, so that is working. Okay, voltage mode, DC. So if we go to common, to pin 1, 2, 3, 4, 5, no 4. Yep, 24 volts. Okay, so just turn the machine round just so it's a bit easier to see the torch height controller there. And we haven't got the plasma machine in here, I've just kept it out of the way for safety for now. Right, so I think, having looked at the instructions for this is the THC controller, SD. I believe this is a later model that puts step and direction out instead of using relays somewhere. Did it say that somewhere in here? I think there was a different model that used relays that controlled the step and direction a different way. So this apparently is a bit more universal, and from what I've read seems pretty straightforward. I've wired it up like that, and you can actually move the head up and down. It's just off camera, but I can move it up and down using the software, so that's okay. So I was just reading through this, and there are a load of defaults, so I'm going to leave those as they are, but there is like a test mode down here, which I'm guessing with the up down arrows when you're in test mode allows you to move the voltage up and down and see what the Z-axis does. I don't know, I guess, and then you can check if it's going in the correct sense or the correct direction there. So it says press the up down keys together, hold for a few seconds, and you can look at the set values for the voltage, I think it said, and then if you want to look at these other ones, hold them down until you see the desired parameters. So we want to go into test. So okay, oh that's cool. So that's cycling through, and that is moving up and down. I don't know if we're supposed to look at the parameters of that, or it's just actually down. The down LED is coming on when it goes up, down, up. Okay, it's inverted. Right, let's fix that. Okay, I just went in. Okay, I just went into the direction menu and switched that round. So now, up and then down, up and then down. Yeah, the Z-axis is moving in the correct sense. And also when this number's too low, it wants to go up, and when it's too high, it wants to go down. Is that the right way around? Actually, I'm not sure about that. I thought when the gap got bigger, the voltage was higher, so you want to go down. So maybe I don't need to flip that round there. I need to flip it in the step and direction software. Oh, no, hang on, no, it says the direction should be consistent with LEDs, which it is. So maybe that's right. So that's going up and that's going down. Okay. All right, let's come out of there. And what are those set points? 120. How do you stop it? Maybe hold them both down. Aha, like that. That's nice. Yeah, I like that. Yeah, it's had some thought put into it. All right. Yeah, within, I don't know, 2 minutes, I've got it going, and instructions make sense. Very nice. Oh, that's it. Last page. Right, I've got to have a think about what's next. Right, I've been spending a little bit of time now with the macros because Obviously with the plasma you want to be able to touch off the work and then retract a certain amount to the pierce height and then do your cut. I had a look around online for different macros. One of them I tried here didn't seem to work really well, even though it was supposed to work with a certain screen set. Anyway, in the end I kind of gave up and heavily modified the code. So you can see here it was originally by CNC for PC on their website, but I've changed quite a lot of it now. So let me take you through what I've got and then what it does. Okay, if we go over to the original M3 macro, it was written by CNC for PC. It tried to read different field values here off the GUI. I couldn't get that to work and it went in the wrong direction. I couldn't seem to change that. There are a few things in here that didn't quite make sense. Okay, so this is the code I've got. I've hard coded some of the values for the pierce height and how far down it's going to probe before it gives up, and the feed rate as well. I may put those into a GUI if I get it working in future, but to be honest it's pretty quick to come into the macro and change it. So then it uses G31, which is the macro to do the probing, and it goes to the correct height at the feed rate you want. Because it isn't like a single line of code, it actually multitasks. So as soon as it's gone off to do that, it will carry on running. So you just got to put this little while execute is moving end while, so basically wait until it stops moving and it's the probe is actually touched and it's actually hit the metal. Or it's run out of height, so it's gone down so far and it's not triggered, and so it stops at that point. Then you have to find out what's going on. So here it checks the LED 37, which is the probe. Now ideally it should have come on, so it's stuck on because it's detected. So it does a little check here, make sure that's the case. If not, it tells you to go away and make sure you got your work set at the top of the slats, so it's definitely going to trigger it. And it then also invokes the reset button and comes out the subroutine. Basically it does an e-stop at that point. Right, the next bit here is, so obviously you've touched off the work, now you've got to back away the correct amount, which is it goes to the where you are now plus the pierce height, so in my case 2mm or whatever you put in. Again, you've got to wait until the machine isn't moving anymore until you do the next thing. Then this command do spin. Now it's kind of thinks it's a spindle, but effectively it's going to fire up the relay that's configured to switch on the torch. So plasma torch will come on. It waits for the time you specified for the pierce time, and then the last thing it does is now this I've commented out. So it switches on the torch height control if it's not already on, kind of basically toggles it. So on here, torch height control on, but because I'm not using the internal torch height control in the software, I'm using it external in hardware. I think I don't need that, and it wasn't behaving as I expected when I put that in, so I've just commented that out so that doesn't run. So effectively, once it's waited for the pierce time, it comes out the routine, and that's it. The torch is on and it's ready to cut. Then switch the torch off after a cut. It will call the M5 macro. So this is as written by CNC for PC. All I did is just spread it out a bit, added some comments so it's a little bit clearer what was going on. So the first thing, it switches off the torch, obviously because you finished the cut. This one, I've actually printed out the manual for all the buttons, LEDs. So this is just the LEDs one, so there's a whole load of them on screen objects, and what each of those are in the GUIs, and there's some other ones as well, there's two other ones, just to work out when it called something what it was actually doing. So this one here is checking if the torch height control was on, and if it is, then switch it off. Now I'm not using that actually. I think I'm going to comment that out because I'm using it in hardware, not in software. Save that. Then it reads which position you want to go back up to, like your save position. I've just hard coded that as 20 because I don't think I have that in the GUI. It waits a little bit of time and then it actually moves the machine to those coordinates. Again, you've got to wait for it to stop moving and then back to absolute coordinate system again so the code can carry on. So that's stopping the torch. Okay, so there's two other things I did. One of them is to home the Z-axis. So you'll see if I push that, it will go up to the and home itself. Okay, and then the other one was to jog the machine down until, just slow it down a little bit. I'm just reenacting what I did. Until it touches off, and you'll see the LED. Come on, where are we? On the probe there. and at that point then zero my Z-axis here. Now I could also do that off the top of the slats. It makes sure it knows where the top of the work is. So let's move that back up again. All right. So a bit faster. All right, and to test this out, I've written a very basic file. So let me just load that in, which is a test file, and I'll go into edit just so you can see what it is. All right, nothing too fancy, just trying to get the basics working. So if I've missed something, apologies. So that's my test file, G90, put it in absolute coordinates. Then we want millimeters for our units, and we're going to use the G54, which is the first work offset. To be honest, I rarely use any of the other ones, but it's useful just to set that. Then we run that M3 routine, which is what you just saw. Oh, will it let me do that? Oh yeah, here we go. Runs this, which does the touch off and then hands control back. Here we go. Actually, let's look at it here. Once, assuming that's okay and it didn't find any error messages, now I've just put a simple cut. So it will go to X10 at read rate 500, so it simulates just a quick cut like that. And then M5 is this one where it will stop and retract the tool. So I'll retract the Z-axis. Let's go back in here, save and exit, and there's the file, and this is what it does. Right, so I've got our file loaded there. We'll hit cycle start and make sure you have zeroed my X and Y, and here we go. So it goes down to probe and then moves forward. There we go. So it looks like we've got the basics covered. Right, I've just edited the file so it now cuts a square out, so we'll just save that. Rewind, okay, and cycle start. So I think the basics are there. Don't forget we're using the hardware for the torch height control, well that's my hope. So we haven't got torch height control on here and I haven't configured it in here to control that, so hopefully that will work, but we'll only know that once we've got the plasma hooked up for real and actually testing it. Yes, it cut a nice square out. The one last thing I want to check then is when it's cutting, if the torch runs into something, does it go into e-stop? So what we're just doing now is checking if this proximity sensor here works, if we collide into something. Obviously I haven't got the torch in there, so I'm just going to push it. Right, here we go, let's cycle start. Touch off. And it's cutting, and let's say, oh, it stopped. Actually it took quite a bit of force, but I guess I can tune that on the springs. So for safety this is on, so it's putting 24 volts on in the normal state, and then when it e-stops it actually breaks that and it goes down to 0. Yeah, so you can go in pretty much any direction. Oh, and I should point out I am not an expert in plasma, this is the first time I've done it, so some of this functionality I'm exploring for the first time. I'm getting to grips with it, so if I made any mistakes, sorry about that. I'm just showing you my step-by-step process and what I'm learning along the way. Right, I think that's probably about all we can do until we hook up the torch and the plasma itself. So I've still got a number of jobs on that. I've got the power cable to swap over to go to the commando socket and put the 6mm square cable on it. I've got to do something with the airline because I ran into a bit of a problem at the back. Yeah, I'm going to need to find a solution for that. And then I need to make sure all the connectors I got, the GX16 connectors, will actually work directly with the torch. But it feels like we're making progress at least. Okay, that's it for this video. I've still got quite a few jobs left to do. I've got to get the end panel cut out, go on the end here just to protect the electronics. I've got to figure out what I'm going to do about the airline that comes out the back of the plasma because the connection's too close to one of the cross members, so I've got to find a solution to that. I also need to rewire the plasma unit, so rather than running off the 13 amp socket, it'll actually run off a commando socket, so I can take it all the way up to 32 amps. And then I've got to rework the airline on the plasma side, depending on what I'm doing, to try and solve the connection problem. I think there's a few other little bits and pieces, but then once those big jobs are out of the way, oh yeah, I've still got to work out exactly where I want this monitor and whether I definitely want it on this kind of stand. It's sort of half in the way. I haven't found an ideal place for it, but probably use it for a bit and then see how we get on with that and see what I ultimately want to do with it. So all that remains is to thank you very much for watching and see you next time.